3.
Oh, it's going?
Yeah.
Okay. Okay, this is what we are working on right now. Your substitute teacher should have handed you this paper. And folks, we're going to be talking about classifying chemical reactions and reaction types. So this is a flow chart. And if you will look at this with me, everybody should have picked this one up, did you?
No.
If you did not, Gracie, you'll get them out to people. I think it's right there. And there are questions to ask here. The first question is there one reactant? And by one reactant, remember, on this side of the chemical equation we have reactants, on this side we have products. Very simple, if you have one reactant, am I going to decoms here? The only kind of reaction it can be is a decomposition. Because if I look at this reaction, if I have one thing, what's the only thing it can do? Go ahead and say it. Don't worry that you're being recorded.
I don't know.
Break it into its elements.
Okay.
So this can break down into magnesium and oxygen. That's all, the only thing that can happen. You want to what? Oh, can you see everything? Okay, he's good. Thank you, Gracie, for helping us.
Stop!
So, when you're looking at this worksheet, the first question you should always ask yourself, is there one reactant? If that is a true statement, then you are looking at a decomposition reaction. If the answer is no, what's our next question?
One product?
Is there one product? If there's one product, and in this case, I'm going to do just the opposite. If my product is MgO, then all I can do to get that is put the elements together. And this calls, okay, it is a synthesis or addition. I always call the second reaction synthesis. So if you see me, the word addition, or the word synthesis, or the word combination, I always do synthesis. The third reaction type, if the answer is no, is, in my opinion, the most difficult reaction type to classify. It's a combustion. So I like to think of combustions like this. The two things you need for anything to burn are a fuel and oxygen. Do you know that? And what's one easy way to put out a fire? Cover it. Because what do we deny it? Oxygen. And of course you have to have fuel. You know, if I run out of gasoline, what happens to your car? Stops running. Most of our fuels contain carbon, hydrogen, and sometimes oxygens. So this is the chemical formula for octane, and that's one of the fuels that you burn in your car. So if you ever have a fuel plus oxygen and your products are CO2 and H2O, CO2 and H2O, this will always be a combustion. What you need to look for are these three items. If you see those, then it's combustion. Now this isn't true every time, but on any worksheet or practice I put together, I always go in this order. Fuel, then oxygen, then CO2, then water. So if you're thinking, man, I don't know what this reaction type is, a good one to think about is combustion. So that's a good one to look at. Okay, we've done 1, we've done 2, we've done 3. Our fourth question is it an element and a compound making a different element and a different compound? And this one is sort of interesting. It's one of my favorite reaction types. And I often think of it as A, there's an element, plus BX, this is a compound. And this is called a single replacement. So these two literally switch places. So which element is going to be alone on the product side? A or B? And if A is going to now be combined with X. So I have a new element and a new compound. And this is called a single replacement. That's a single replacement. And these are usually pretty easy because it is literally an element in a compound. So a really good one is copper. That's an element copper. And you know what a shiny new penny looks like? That's copper plus silver nitrate. So there's an element and a compound. I'm going to put E and C for element and compound. And this is one that I often do. I'll be demoing this one for you. And now which element is going to be by itself on this side? Yep, silver. So we're literally going to make silver plus a Cu, and that'll be, you don't need to know why that is yet, I'll explain that later. So it makes a new element and a new compound, single replacement. These two elements switch. One thing is replaced, a single replacement. Last but not least, double replacement. A double replacement reaction. These look complicated, but I think they're probably the easiest ones to deal with. And my favorite way of representing these is AX, which is a compound, plus BY, which is another compound. And then these two are going to go together, and these two are going to go together. This is going to be a double replacement, because two things are switching spots. Double replacement. Now the only problem that people have with this one is they always write the AY correctly, but you have to remember to put BX, because this is a metal and this is a metal. And metals always go first in a chemical equation. So do you understand that often I see people write this incorrectly as XB? That's wrong, because the metal always has to go first. So don't forget, the first two letters go first, because these like the first two letters in the alphabet, they go first. That's why I like to use this format. An example of this one, a very simple one, would be NaCl plus, how about barium sulfate? No, can't do barium sulfate. I'm changing my mind. Na2SO4 plus BaCl2. So I've got sodium sulfate, this is a metal, and this is a metal. So this is going to switch places and go with that. This is going to switch places and go with this. So my first compound is going to be NaCl, and we'll practice why it's not NaCl2 more another day, plus BaSO4. And of course that